In this video, I will explain how to calculate compensating variation and equivalent variation in economics. So let's start with a couple quick definitions. Compensating variation, often abbreviated CV, this is the amount of money that must be given or taken from a consumer after a price change to restore them to their original utility level. And equivalent variation, often abbreviated as EQ, this is the amount of money that, if given or taken from the consumer at the original price, it would produce the same utility change as the actual price change. So to see how to calculate these two values, let's consider the following example. Suppose U, the utility that a consumer gets, is equal to X times Y, where X is the quantity consumed of good X and Y is the quantity consumed of good Y. M, their income, is equal to $100. The price of X is equal to $10. The price of Y is equal to $1. If the price of X increases to $15, so from $10 to $15, find the compensating variation and the equivalent variation. So the way that we're going to solve this problem is we're first going to write down what is the consumer's budget constraint. So the budget constraint is M, the consumer's income, is equal to the price of X times the quantity of X plus the price of Y times the quantity of Y. Now let's go ahead and plug in all of these values that we know. So we know that M, the income, we're told is $100. So we can say 100 is equal to the price of X. So the original price of X is going to be $10. So let's write 10 times X plus the original price of Y is $1. So we'll have 1 times Y. So we can just write Y. So here is our budget constraint at the original prices. Next, we need to recognize that this consumer will be able to maximize their utility when the following is true. The marginal utility of X divided by the price of X is equal to the marginal utility of Y divided by the price of Y. So when this is true, the consumer is able to maximize their utility. So let's go ahead and find what is the marginal utility of X and the marginal utility of Y. So the marginal utility of X, that's simply going to be the derivative of the utility function with respect to X. So the derivative of this utility function with respect to X is simply Y. So we would just take the derivative of X, which is 1, and then Y comes along for the ride. And similarly, the marginal utility of Y, that is equal to the derivative of the utility function with respect to Y. So the derivative of this utility function with respect to Y, we would just take the derivative of Y, which is 1, and then X comes along for the ride. So that would just be X. So let's go ahead and plug in these values into this equation. So we would get Y over the price of X is equal to X over the price of Y. Now we're going to solve for X and Y. So to do that, we can cross multiply and set those values equal to each other. So we'll find that the price of Y times Y is equal to the price of X times X. Now it's pretty easy to solve for X and Y, so we can see that X would be equal to the price of Y times Y over the price of X, and we can see that Y would be equal to the price of X times X over the price of Y. Alright, now what we can do is we can take these values for X and Y and plug them into this budget constraint equation. And that's going to tell us the optimal quantities of X and Y to consume based on the prices and based on our income. So let's start by plugging in X, this value right here, into the budget constraint. So we would get M is equal to the price of X times, we're going to plug in this value for X. So we get the price of Y times Y divided by the price of X. And then we'll have plus the price of Y times Y. So this price of X will cancel out with this price of X, and we'll be left with the price of Y times Y plus another price of Y times Y is equal to M. So we can say M is equal to 2 times the price of Y times Y. Now we can solve for Y by dividing both sides by 2 times the price of Y. We'll find that Y is equal to M divided by 2 times the price of Y. So what this tells us is this is the optimal quantity of Y to consume to maximize our utility based on income and the price of Y. And we can repeat the exact same process by plugging in this value of Y into the budget constraint, and we'll find that X is equal to M divided by 2 times the price of X. So what this tells us is that these are the optimal quantities of X and Y to consume to maximize our utility. So now that we know these two quantities, we can plug them into our utility function and we can find what is our utility at the original prices and what is our utility at the new prices. So I'll clear a little bit of space here. All right, so here are the values that we found for x and y. Let's plug these into the utility function to find our original utility at the original prices. So we would say that u, let's label it u sub 0. So this is our original utility. That's equal to x times y. So we'll have this quantity times this quantity. So we know for m, our income is 100. So we'll say 100 divided by 2 times the price of x. We're told the original price is $10. So let's plug in a 10 right there. And then we're multiplying that by y, which is going to be 100 divided by 2 times the price of y. Y is just $1. So we'll say times 1. So we get 100 divided by 20. This is 5. And we're multiplying that by 100 divided by 2. That's 50. So 5 times 50, that's 250. This is our original utility level at the original prices of good x and good y. Now let's find what's our utility level. Let's label that U1 at the new prices. So remember, the price of good x is jumping from $10 to $15. So let's find out what our utility is at that level. So we would have 100 divided by 2 times 15 this time, so our new price. And then y is not going to change. So we're still going to have 100 divided by 2 times 1. So the price of good y is still 1. So we're going to end up with 100 divided by 2 times 15 is 30. So this first parentheses comes out to about 3.33, and it will just be repeating. And then we'll still have multiplied by 100 divided by 2 is 50. So when we multiply these two values together, we get about 166.67. So I went ahead and rounded this to 2 decimal places. So we can see that our utility drops. When the price increases, our utility drops from 250 to 166.67. And that's simply because when the price increases, we're not able to buy as much of good X. So it makes sense that our utility would decrease. So now that we've calculated these two utility values, we have everything we need to finally calculate the compensating variation and the equivalent variation. So I'm going to clear a little bit of space here again. Okay, so I've rewritten the original utility level that we obtained at the original prices and the new utility level that we obtained at the new prices. I've also rewritten the optimal quantity of both x and y to consume to maximize our utility. So let's start by finding what is the compensating variation. So this is the amount of money that must be given or taken from a consumer after the price change to restore them to their original utility level. So here's how we're going to solve this. Our original utility level is 250. So here's what we can say. 250, this is our u, is equal to, we're going to plug in x and y right here into this utility function for x and y. And we're going to figure out what is m. So what is that total income that they would need to achieve this original utility level? So we'll say x times y. So we'll have m times 2 times the price of x now is 15. So this is after the price change. And we're multiplying that by m times, we have 2 times the price of y. So the price of y has stayed $1 this whole time. So we're just going to have m divided by 2 times 1. So now we'll be able to solve for m. So let's do that. So we get 250 is equal to, here we have m divided by, this will be 30, times m divided by 2. So then we'll get 250 is equal to, we'll have m squared over 60, so 30 times 2 is 60. To solve for m, we can multiply both sides by 60. So we'll find that m squared is going to be equal to 250 times 60, that's 15,000. And to solve for m, we'll take the square root of both sides, and we'll find that m is equal to, the square root of 15,000 is about 122.47. So we're saying we need this much income to achieve this original level of utility after the price change. So the compensating variation, in other words, what this consumer needs to be compensated with, is simply the difference between this income, this new income, minus the old income of $100. And we find that will be equal to 22.47. We'll say dollars. So the consumer needs to be compensated with $22.47 in order to restore them to this same utility level. So that's our compensating variation. Next, we can find our equivalent variation. So I'm going to clear a little bit of space again. Okay, now let's calculate the equivalent variation. So that's the amount of money that, if given or taken from the consumer at the original price, it would produce the same utility change as the actual price change. So remember the utility change, the new utility was 166.67. So to solve for the equivalent variation, we can say 166.67 is equal to, once again, we're going to plug in these x and y values into our utility function. So we'll say m divided by 2 times the original price of x. So the original price of x is $10. So we'll say times 10. And then we're multiplying that by m divided by 2 times the price of y, which is 1. So now what we can do is we're going to solve for m. We're going to figure out what new income would produce this same utility level as the price change. So we'll find that 166.67 is equal to, we'll have m divided by 20 times m divided by 2. So we'll find 166.67 is equal to m squared over 40, so 20 times 2 is 40. If we multiply both sides by 40, we'll find that m squared is equal to about 6,666.8. If we take the square root of both sides, we'll find that m is equal to about 81.65. So if we reduced the consumer's income to $81.65, it would produce the same utility level as the actual price change. So to find our equivalent variation, all we have to do is take our original income of $100 and subtract this new income, so minus 81.65. And that comes out to 18.35, and we'll say dollars. So our equivalent variation is $18.35. So let's quickly summarize these results. So to summarize, the compensating variation value that we found, here's how we interpret that. The consumer would need to be compensated with $22.47 to maintain their original utility at the new prices. So that's how we interpret the compensating variation. And the equivalent variation value, we interpret that to mean taking away $18.35 at the old prices would reduce the utility to the same level after the price increase. So that's how we interpret our equivalent variation.